All right, today we're going to take a look at the last couple of sections in Module 2. And that third section in Module 2 is percent increase and percent decrease. So we're sort of along the lines of what we were doing in the last class when we had the percent equation and we were finding basically percent increase and decreases. So we'll take a look at that. And also in the last section the last section in module 2 deals with compound interest, but there's actually two types of interest that we're taking a look at in the last section. One is called simple interest and the other is called compound interest. Okay, so we're going to get started with percent increase and percent decrease. And there is a formula for the percent increase or the percent decrease. Is it dark enough? All right, so here's that formula for percent increase or decrease. So the percent increase or decrease, that's equal to the change in amount. So if that change in amount goes up, that's a percent increase. So like if you're at your job and you get a salary raise, that change in amount from your old salary to your new salary, that's the change in amount. Okay, so if the amount goes up, it's an increase. If the amount goes down, it's a decrease. So let's just say you're at a job, you get a demotion or whatever, and you're getting paid a lower rate. So the original rate minus the lower rate, that would be a percent decrease. So a percent decrease is nothing that's negative. Okay, it's just simply lowered. So it's the change in the amount over the original amount. So the original amount is always your starting point. Now, when you calculate the percent increase or percent decrease, you're going to get a decimal. And in order to make that decimal a percent, so I'm just going to write that down. Change a decimal to a percent. And you're going to do the following. You're going to move the decimal two places to the right. And you're going to add the percent sign. So here's some examples. 0.3 as a percent, right? So I'm going to just simply move that decimal two places to the right. So for 0.3, the decimal is in front of the 3. I'm going to move it once to the right. It's behind the 3. I'm going to move it twice to the right. I'm going to add a filler 0, and then I'm going to attach the percent symbol. Right? So therefore, 0.3 as a decimal is the same as 30%. And just taking a look at another example, let's say you had to write 1.3 as a percent. So in 1.3, the decimal is in front of the 3. So here again, I'm going to always move that decimal twice to the right. So if I move it one place to the right, it's behind the 3. If I move it two places to the right, I add a filler 0. and then I add my percent symbol. So 1.3 as a decimal is 130%. Okay. So no matter how far out that decimal is, so for example, if you have 0.03, and if you wanted to change that to a percent, right, you move that decimal 2 places to the right and you should get 30%. And then vice versa. If you're given a percentage and you're asked to convert a percent to a decimal, okay, what just happened? Okay, I just have no idea what happened. Change a percent to a decimal. Right, we're just going to reverse the process. You're going to drop the percent symbol, and move the decimal 2 places left. So for example, let's say you have 1,000%, and you're asked to change that to a decimal. I'm simply going to drop the percent sign. All right, so on 1,000%, I'm going to drop the percent sign. I'm going to take the decimal, right, which is understood to be behind that last zero, and I'm going to move it 2 places to the left. So 1,000% as a decimal would simply give us 10. All right. So now let's just take a look at that percent equation, or the percent increase and percent decrease formula. Take a look at that in some examples. All right, now in some of these problems, like for instance, these salary increase problems, in some problems, they're asking for the new salary. So that would be whatever that salary increase is on top of what the person already makes. On other examples, they simply want the amount of the increase. Okay, so keep that in mind. Some of these things want the total amount, and then some of them are simply just asking for the amount of the raise or increase or decrease. So let's take a look at this first example. It says if a person earns $22,300 and gets a 4% increase in salary, what is the new salary? Okay, so let me just paste this over into OneNote. All right, so here it is. So if a person earns $22,300 a year and gets a 4% increase in salary, what's the new salary? So we're going to use that percent increase or decrease equation. So here again, it's percent increase or decrease. That's equal to the change in amounts divided by the original amount. Now we can sort of equate this to that percent equation, because on one side of the equation we have the change in amount over the original amount, and on the other side we have the percent increase or decrease. So I'm going to rewrite this percent increase or decrease as, and I'm just going to flip this around a little bit, the change in amount divided by the original amount that's equal to percent over 100. So it looks similar to that percent equation where we had is over of is equal to percent over 100. And we use the cross product property to solve it. We can actually utilize that same cross product property. Okay? And this is somewhat a modified percent equation. So we want to know what is the person's salary. So now this particular equation is only going to give you either the change in amount or the original amount, depending on what you're solving for. It's not going to give you the person's new salary. So what we're going to do to find the person's new salary is we're going to find the change in amount, and then we're going to add that back to the salary. All right, so as I set this up, we're trying to find the change in amount. So I'm going to write that as N, that's our unknown, divided by the original amount or the original salary, which is $22,300. And there was a 4% increase in salary. So I'm merely going to drop the percent symbol, right? And I'm going to write 4 in the numerator and 100 in the denominator. And I'm just going to simply cross multiply and solve. So if I cross multiply, N times 100 is 100 N. If I cross multiply 22,300 by 4, we get 89,200. $89,200. I want to solve for N, so the opposite of multiplying N by 100 is to divide by 100. So I'm going to divide both sides by 100. Right. On the left-hand side, the 100s cancel, so we're left with N, right? And N represents the change in amount. And 89,200 divided by 100, right? I'm going to kind of cancel those zeros off on the end. So our change in amount is $892. Now, that's not the new amount or the new salary, that's just the change in salary. So to find the new salary, right, we're going to take the original salary, which was 22,300, and we're going to add the increase of $892. And we're going to get 23,192. So $23,192 should be the new salary. All right, now that was sort of long-winded. And we talked about some things in the last section where I can actually get this value in one step versus these two steps, right? First find the change in amount and then add that back to your total amount. I could also do this. Or since the change in the amount was 4%, right? So the total whole is 1%. So I want to increase that the 100% by 4%. So I'm going to add those two together. 100% plus 4%, that equals to 104%, right? If it's an increase, I'm going to add to 100%. If it's a decrease, I'm going to subtract from 100%. So now if I change the 104% to a decimal, that's going to equal to 1.04, right? So I would just drop that decimal, drop the percent symbol, move the decimal 2 places to the left. I can now take that original salary, which was $22,300, and I can multiply that by 1.04. So if I multiply those two things together, 22,300 times 1.04, okay, we get exactly $23,192 in one step versus two steps. So 23,192. So in this section, I would only use the percent equation, or the percent increase or decrease equation, if I was asked to find the change in the amounts. Other than that, a more powerful way to do it would either be, if it's an increase, you add 100%. If it's a decrease, you subtract 100%. All right, let's take a look at another example. For example number 3, it says a supermarket increased the price of cheese that sold for $1.73 per pound by 2%. What is the new price for a pound of this cheese, and round to the nearest cent? Okay, so we'll always round money to the nearest hundreds. So I'm going to do that same thing I did before. Since this is a percent increase and they're asking for the new price, I can simply take 100% and add to that 2%. So that gives me 102%. 102% as a, and now I can simply multiply $1.73 by 1.02, and that would give me the new price. Okay, so I'm gonna just do that on the calculator right here. So I'm gonna take $1.73. I'm gonna multiply by 1.02, right, which is 102%. And if I round to the nearest cent, that's the same thing as rounding to the nearest hundredths place, or 2 places after the decimal. So notice that new block of cheese should be $1.76. All right, any questions about an increase? So now I want to take a look at a decrease. So problem number 4, let's look at problem number 4. And it says for calorie content. And I'm actually going to copy this over. Number 4. Okay, did it save on? right, this is number 4. So it says calorie content. A certain light beer has 25% fewer calories than its regular beer, right? So this would be a percent decrease. If the regular beer has 120 calories per bottle, how many calories are in the same size bottle of light beer? So since this is a percent decrease, instead of adding 25% to 100%, I'm going to subtract. So I have 100% minus 25%. That's going to give me 75%. If I convert 75% to a decimal, right, I would drop the percent symbol, move that decimal 2 places to the left. So that's going to give me 0.75. I'm then going to take the original amount of calories, which is 120, and I want to multiply that by 0.75. So if I punch that in on the calculator, 120 times 0.75, so notice we subtracted, we should get a total of 90 calories. Right, so if I take a look at the number of calories, it should be 90. That was in one step. Now, if you wanted to do it using the percent increase or decrease, I also do it that way. Okay, but this is like the straightforward method. With one step. Okay, so I don't want to slight that percent increase or decrease equation. So if I wanted to use a percent increase or decrease formula, so we had the change in amount over the original amount, that's equal to percent over 100. So notice this won't give you the new amount, right? The only thing we can find here is the change. So I want to find the change in calories, so that's going to represent N divided by the original amount of calories, which is 120. I'm going to set that equal to 25%. So for 25%, I simply remove the percent symbol, and in the numerator, I put 25 divided by 100. So now if I cross multiply, N times 100 is 100N. And if I cross multiply 120 by 25, we get 3,000. I want to solve it for N, which represents the change in amount. So the opposite of multiplying N by 100 is to divide by 100. So I'm going to divide both sides by 100. On the left-hand side, the hundreds will cancel. I'm left with N. On the right-hand side, I can cancel those 2 zeros off the N. So N is 30. So now we can go back and find the amount of calories. So we take the new amount of calories. So we take the original amount of calorie, which is 120, we subtract off the change, which is 30, and we get 90. So you can do it straightforward in one step by either adding or subtracting from 100, okay, and multiplying by the original amount, or you can do it in two steps. All right, any questions about percent increase or decrease? Okay, all of the problems, okay, in this set are pretty much the same. Okay, so but let's take a look at number 9. Let me copy this over. All right, so here's problem number 9, and we are given a graph. Okay. All right, so it says the graph shows the rising cost of healthcare. What is the percent increase in healthcare costs from 2002 to 2014? So now for this particular problem, I will have to utilize the percent increase or decrease formula, right? So the first thing I want to do is find the change in amount. All right, so if we look at 2014, it seems like it's 3,585.7 was the estimated healthcare cost in billions. So that's 3,585.7 minus the healthcare cost in 2002, which looks like 1,559. Right, so that's the change in amount divided by the original amount. So the original amount was in 2022, which is 1,559. Okay. So I'm going to simplify the numerator. So I'm going to subtract the 2. So 3,585.7 minus 1,559, and I get the change in amount is 2,026.7 divided by 1,559. So I'm going to divide by 1,559. That equals to 1.3. And if I change 1.3 to a percent, right, I would move that decimal twice to the left. So 1.3 as a percent would be 130%. Right. So the rise in healthcare costs from 2002 to 2014 would be 130%. So not to slight the percent increase or decrease equation because you will need those. All right, now there's a couple of questions at the end. Let's say number 13. And I'm going to copy that over. All right, so let's take a look at number 15. All right, it says a bedroom set normally sells for $1,716 and it's on sale at 15% off. The sales tax is 7%. What is the total price of the bedroom set if it was bought while on sale? So we're going to do this in 2 steps versus doing it all in 4 steps. So the first thing I want to do is I want to find 15% of the 1760, right? So since this is on sale, this will be a percent decrease, right? So I'm going to take 100% minus 15%, and that's going to give me 85%, right? So I'm actually finding the sale price of the bedroom set, right? Since it's on sale, that's a percent decrease, so I'm subtracting 15% from 100%. I'm now going to change 85% to a decimal. So I would drop the percent sign, I will move that decimal 2 places to the left. So 85% is 0.85. I'm now going to take 1760 and I'm going to multiply by 0.85. This is going to give me the sale price, right? The 15% off price. So I have 1760 times 0.85, and we get $1,496. That's the sale price. Now, when we go to the cash register, they're going to charge us 7% sales tax. So that's a percent increase of 7%. So for the sales tax rate, I'm going to take 100%. To that, I'm going to add 7%. Right, so 100% plus 7% is 107%. 107% as a decimal is 1.07. So I'm going to take the price, the sale price, which is $14.96, and I'm going to multiply that by 1.07. This should give me the price with sales tax added. So I'm going to calculate that. So I have $14.96. I'm going to multiply that by 1.07. And remember that money is always rounded to the nearest hundred. So that bedroom set should be $1,600.72 with sales tax. All right, so we should have $1,600.72. I did look at the viewing example and they worked it out using quite a few steps. But here I simply subtracted 100% or 15% from 100% to get the sales price. And then I added 7% to 100% to get the price with the sales tax. All right, so let's take a look at the last section, and it deals with simple and compound interest. All right, so here are the formulas for that. The simple interest formula is I is equal to P times R times T. This simple interest formula only gives you the amount of interest. It does not give you the amount in the account at time T. So to put some meaning behind these letters, I, that's equal to the interest earned. P is for the principal. Now, the principal can be the money invested or the money borrowed, right? So in some of these examples, you're going to see where a person puts so much money in the bank. In other examples, you're going to see where a person borrowed money. Okay, so principal is either borrowed or invested. R is the rate. That's the interest rate, and that interest rate is set by the bank. T is for the time, but the time has to be in years. And for accounting purposes, there are 360 days in 1 year. All right, these for accounting purposes. Could be a 365 or whatever leap year, but we're using 360, okay, for accounting. So we're going to use this formula to find interest. Okay, so notice it doesn't give you the amount in the account. It only gives you the interest. Okay, so I believe the first, and this is in section 2.4, the first 8 problems, they deal with simple interest. Problems 9 through 15, they deal with compound interest. There are 2 different formulas for each one. So we're just looking at the simple interest first. So let's take a look at the very first problem. And it's a savings account example. And it says that a man invests $2,000 in a savings plan that pays 3% per year. How much money will be in the account at the end of the year? So we'll just copy this over. All right, so we're going to use this simple interest formula. So we have I is equal to P times R times T. So our principal is the $2,000 invested. The rate is 3%, but I'm going to change that 3% to a decimal. So as a decimal, that should be 0.03. And the time has to be expressed in years. So in this case, T is going to equal to 1. And we're going to see an example shortly where the time is like in days. So I, which is the interest, that's going to equal to 2,000 times 0.03. So I'm just going to calculate this up. 2,000 times 0.03, and we get $60. So that's the interest that it earned. But it's not asking for the interest. It's asking for the amount that's in the account. So the amount in the account that's going to be equal to the $2,000 that was invested plus the $60 in interest. So after 1 year's period of time, there should be $2,060 in that account. So keep in mind on what the problems are asking you for. Some of the problems only ask for the interest. Other problems like this one, they want the entire amount that's in the account. All right, any questions about that first example? Okay, let's look at another example, 2%. Let's look at number 6, right? It's number 6 is a student loan example. A student takes out an emergency loan for tuition, books, and supplies. The loan is for $800 with the interest rate of 9%. How much interest does the student pay if the loan is paid back in 60 days? Right? So notice this question asks for the amount of interest that they pay back. Okay. So we're going to use simple interest. Okay, one no close. All right. So we're going to calculate the interest. So I is equal to P times R times T. The principal is $800. The rate is 9%. And 9% as a decimal is 0.09. And then the time has to be expressed in years. So I have to convert 60 days into years. So I'm simply going to take 60 and I'm going to divide by 360. So you take however many days, divide that by 360, and that's going to turn that into a year's period of time. So now we're just going to calculate the interest. So P is 800 times R, which is 0.09, times the time, which is 60, divided by 360. All right, so I'm going to put that in my calculator as 800 times 0.09 times 60 divided by 360. And I have a total interest of $12. So just to pull that back up, I'll put in 800 times 0.09 times 60 divided by 360. and that gives us $12 in interest. Right, so this question asks for the interest alone. So that interest should be $12. All right, so those are the simple interest type problems. Now the problems that say compound interest, and it will specifically say compound interest, you're using the compound interest formula. And here's that formula. A is equal to P times 1 plus R over N raised to the N times T power. And in this formula, A is the amount in the account at time T. So unlike the simple interest formula where you have to go back in and add the interest to either the loan or what you invested, this formula gives you the amount in the account. P is the principal, right? That's the money invested or the money borrowed. R is still the rate. T is still the time in years, right? So if you're given days, you have to divide by 360. So that still applies for these formulas. And then there's something called N. N is the number of compoundings per year. So if the number of compoundings a year is annually, N is equal to 1. If it's semi-annually, N is equal to 2. Let me just change these. If it's quarterly, N is equal to 4. Right, so A is the amount in the account at time T, P is the principal, R is the rate, T is the time in years. So for accounting purposes, there are 360 days in a year. N is the number of compoundings annually or per year. So if it says the number of compoundings is annually, N is going to equal to 1. Semi-annually, N is equal to 2. And quarterly, N is equal to 4. All right, so let's take a look at a compound interest example. Let's look at number 9. And in these problems, you're going to see the word compounded annually. When you see the word compounded, then you should use that compound interest formula. So problem number 9 says a woman puts $6,000 into a savings account that pays 5% compounded annually. How much money is in the account at the end of 2 years? So since we see the word compounded annually, we're going to use the compound interest formula. All right, so A is equal to P times 1 plus R over N raised to the N times T. So P is going to equal to 6,000, right? That's the number that the amount deposited. R is equal to 5%. And if we change 5% to a decimal, we have 0.05. N is going to equal to 1, right? Because it's compounded annually. So compounded annually, N is equal to 1. And T is going to equal to 2. All right, so substituting in all of those values, A is going to equal to 6,000 times 1 plus R over N. So R is 0.05 and N is 1. So R over N is going to give us the value of 0.05. We have to raise that to the N times T power. So notice that N is 1, T is 2. So 1 times 2 is 2. Right, so this is going to give us the amount in the account after 2 years. So I'm going to put that into the calculator. So we have 6,000 times, and I'm going to use a set of parentheses to begin parentheses, 1 plus 0.05. I'm going to close off the innermost parenthesis, and then I'm going to raise that to the second power. So I'm just using a basic calculator on the computer, and this x to the y, that's my exponent key. All right, so notice it pops up what's called a caret. I'm going to raise that to the second power, and if I hit enter, I get $6,615. And you will never get that in the bank. So the amount in the account after 2 years should be $6,615. So notice that this doesn't really separate out the interest. It adds the interest back into the amount into the account. Let's see, number 11. We'll take a look at number 11. This is compounded quarterly. So it says that $9,000 is invested in a savings account that pays 7% compounded quarterly. So remember, for compounded quarterly, N is equal to 4. How much is in the account at the end of 1 year? This was number 11. All right, so we're going to do the same thing. We're going to use that compound interest formula. So that formula, once again, is A is equal to P times 1 plus R over N raised to the N times T power. P is going to be 9,000. Right, that was the amount of money invested. R is the rate, which is 7%. And if we change 7% to a decimal, we have 0.07. It's compounded quarterly. So n is going to equal to 4. And the time is 1 year. So t is going to equal to 1. So I'm just going to substitute all this stuff into the formula. So A is equal to 9,000 times 1 plus R over N. So R is 0.07 and N is 4. Raised to the N times T power. So N is 4, T is 1. That gives us 4. All right, so if we put this into our calculator, we have 9,000 times, I'm going to open up a begin set of parentheses, 1 plus 0.07 divided by 4. I'm going to close off that set of parentheses, and I'm going to raise that to the 4th power. Right, so we get $9,646.73. So the amount in the account after 1 year, right, should be $9,646.73. All right, any questions about compound interest? Okay. Now there is one problem at the very end, and it just wants you to basically change the interest rate. It's still using that same formula, right? You still have A is equal to P times 1 plus R over N raised to the NT. But it wants you to calculate the amount after 10 years for 6%, for 7%, for 8%, and for 9%. So it's actually like 4 problems rolled up into one. All right, so I'm going to stop the recording.